Right now, growing through the cracks in your sidewalk, there is almost certainly a plant with thick red stems and small paddle-shaped leaves spreading flat against the ground. It is succulent. When you break a stem, it's juicy inside, almost translucent. You've almost certainly seen it. You've almost certainly pulled it out and thrown it away, or sprayed it with herbicide, or run it over with a lawnmower. That plant is called Purslane, Portulaca oleracea. And what I'm about to tell you about it will permanently change how you look at your driveway. Purslane contains more omega-3 fatty acids than any other leafy vegetable ever measured. Not marginally more, dramatically more. 100 grams of fresh purslane leaves contains 300 to 400 milligrams of alpha-linolenic acid. Spinach contains about 60 milligrams per 100 grams. Iceberg lettuce contains about 27 milligrams. Purslane contains 5 to 7 times more omega-3s than spinach, 15 times more than iceberg lettuce. The 6 times more than salmon figure requires one clarification worth making up front. That comparison refers specifically to ALA, alpha-linolenic acid, the plant-based omega-3, measured per gram of fresh weight against an equivalent serving of salmon flesh. Salmon contains more total omega-3s by absolute weight, including the marine forms EPA and DHA. But purslane does something no other land plant is supposed to do. It also produces EPA directly, in trace amounts, the same marine omega-3 found in fish oil, which land plants are biologically not meant to synthesize. When Dr. Artemis Simopoulos of the National Institutes of Health first published this finding in 1992, other scientists questioned whether the samples had been contaminated. They hadn't been contaminated. Purslane also contains 7 times more vitamin E than spinach, 6 times more beta-carotene than carrots, and significant concentrations of potassium, magnesium, calcium, vitamin C, and melatonin. It is, by virtually every nutritional metric we have, one of the most nutrient-dense plants ever systematically analyzed. It has been eaten continuously for thousands of years across multiple continents. Half the world still eats it today. In the United States, the USDA lists it as a noxious weed in 42 states. So here's the question this video is going to answer. How did we get here? How did a plant that has fed human beings for 4 millennia become something that American homeowners pay $12.99 a bottle to exterminate? The reason isn't about biology. It isn't about toxicology or taste. It's about economics. And once you understand the economic argument, you'll never look at a weed killer the same way again. In 1960, an American physiologist named Ancel Keys launched one of the most ambitious epidemiological studies in the history of nutrition. The 7-country study tracked 12,763 men across 7 countries for 50 years, trying to understand why some populations had almost no cardiovascular disease, while others were dying from heart attacks at epidemic rates. The results from the Island of Crete were anomalous in a way that took decades to fully explain. The Cretan farmers in Key's study consumed some of the highest fat diets he measured, more than 35% of their daily calories from fat. According to the nutritional consensus of the 1960s, they should have been dying from heart attacks at alarming rates. Instead, they had the lowest cardiovascular mortality in the entire study, lower than Japan, lower than Finland, lower than anywhere. For 20 years, researchers credited olive oil, the Mediterranean diet in general, maybe the red wine. Then in the 1980s, a team went back to the frozen blood samples from the original Cretan subjects and ran a different analysis. They were not looking for cholesterol. They were looking for omega-3 fatty acids. The Cretans had 3 times the omega-3 levels of the Dutch subjects in the study, but they were not eating 3 times more fish. They were eating purslane every single day, in salads, in stews, sautéed with whatever was on hand, and they fed it to their chickens and goats, so when they ate eggs and meat, they were getting omega-3s amplified through the entire food chain. The entire island's exceptional cardiovascular health could be traced, at least in part, to a plant that grew wild in every field, requiring no cultivation, no irrigation, no purchase. Researchers decided to test whether that dietary pattern could actually save lives. The Lion Diet Heart Study took 605 patients recovering from heart attacks and split them into 2 groups. Half followed the standard low-fat cardiac diet recommended by mainstream medicine. Half followed a Mediterranean-style diet rich in omega-3 fatty acids, including purslane, walnuts, and fatty fish. After 5 years, the Mediterranean group had 70% fewer deaths. Not 70% fewer heart attacks. 70% fewer deaths from all causes. The data was so dramatic that the trial was stopped early, because keeping the control group on the standard American cardiac diet had become ethically indefensible. The nutritional numbers from Part 1 weren't abstract. They were operating in the real world, inside a population that happened to eat a weed, and producing the most dramatic cardiovascular outcome researchers had ever measured. In 2022, a team of researchers at Yale, led by Dr. Erica Edwards, published findings in Science Advances that rewrote what plant biologists thought was physically possible. They had been studying purslane because it did something that seemed to contradict established photosynthesis science. It thrived in extreme heat and extreme drought while growing faster than almost any other plant in the same conditions. Most heat-adapted plants grow slowly. Drought-tolerant plants sacrifice growth for water conservation. Purslane refused to make that trade-off. It did both simultaneously. Here's some necessary background. Plants have evolved 3 major photosynthesis systems. C3 photosynthesis is the standard. It works well with abundant water and moderate temperatures, and most leafy vegetables use it. C4 photosynthesis, used by corn and sugarcane, concentrates carbon dioxide more efficiently and handles high temperatures, but still requires regular water. CM photosynthesis, used by cacti and succulents, is the drought specialist. These plants open their pores at night to collect carbon dioxide when temperatures are cooler and evaporation is reduced, then seal their pores during the day. It's extraordinarily water efficient, but the trade-off is slow growth. Scientists had known purslane could perform both C4 and KM photosynthesis. They assumed it used one system in one part of the leaf and the other system in another part, 2 separate processes kept physically segregated from each other. When the Yale team mapped gene expression at the individual cell level, they found something that shouldn't exist. Both systems were operating in the same cells at the same time. C4 during the day for rapid growth. KM overnight for drought survival. And, this is the part that stunned the researchers, the carbon captured by the CAM process at night was feeding directly into the C4 pathway during the day, acting as a carbon reserve that supercharged daytime growth. No other plant on Earth does this. It's not just rare, it's a novel biological architecture that scientists had assumed was impossible. The Edwards team called it a super photosynthesis system. Purslane survives on roughly 1/5 of the water corn requires. It grows vigorously in soil so saline that most crops would die within days. It tolerates temperatures that shut down photosynthesis in most leafy greens. In a world where climate projections show expanding zones of heat and drought across the agricultural regions that feed billions of people, this is exactly the biological toolkit that agronomists have spent decades trying to breed into staple crops. It already exists, growing in your driveway. So why is purslane classified as a noxious weed? Let's be precise about what that classification means and doesn't mean. Noxious weed is a legal and regulatory designation, not a botanical or toxicological one. It doesn't mean the plant is poisonous. It doesn't mean it damages ecosystems. In most states, it means the plant has been identified as a management problem for commercial agriculture, typically because it competes with cash crops for soil nutrients and water. Purslane absolutely does compete. In a monoculture corn or soybean field, established purslane will reduce yields. That part is real. But here is what the agricultural extension literature almost never addresses. Purslane's status as an agricultural pest is entirely a function of how we've chosen to farm. In a monoculture system, purslane is a competitive weed. In a kitchen garden, a polyculture plot, or a fallow field, it is a self-seeding, drought-tolerant, nutritionally exceptional food source that requires zero inputs. Here is the economic reality underneath that distinction. You cannot patent purslane. It is reproduced freely for millennia. Its genetic material is public domain, and any attempt to create a proprietary variety runs into the fundamental fact that a single plant produces up to 240,000 seeds per year, each remaining viable in soil for up to 40 years, with every stem fragment that contacts soil rooting into a new plant. The entire industrial toolkit, from patented seeds and specialized irrigation to synthetic fertilizers, is rendered obsolete by a plant that prefers drought and poor soil. You cannot make a farmer dependent on purchasing purslane seed annually. You cannot charge a licensing fee for purslane genetics. You cannot sell specialized harvesting equipment for a crop traditionally gathered by hand. The entire economic architecture of industrial agriculture generates zero revenue from purslane, and so the herbicide market built around purslane control is substantial. Bayer, Syngenta, and Corteva all sell products specifically formulated to kill it: metolachlor, isoxaban, indaziflam, 2,4-D, a roster of herbicides engineered partly or primarily to eliminate a plant that human beings have been deliberately eating since the Bronze Age. The 2024 global herbicide market was estimated at approximately $40 billion. A meaningful fraction of that market exists because American agriculture has decided that purslane must be systematically removed from fields growing commodity crops. What you can do, what has been done, is fund decades of research into purslane elimination, publish thousands of extension bulletins teaching farmers to recognize and destroy it, and sell herbicides to accomplish that destruction at scale. The result? Multiple generations of American farmers have been trained to view one of the most nutritious plants on their land as a threat requiring immediate chemical response. While American homeowners were paying to kill it, the rest of the world was eating it. In Greece, purslane salad, dressed with olive oil, lemon, and feta, is a summer staple. In Turkey, semizotu is sautéed with onions and served alongside yogurt. In Mexico, verdolagas cooked with pork shoulder and tomatillos is a dish that dates to pre-Columbian cuisine. In China, it's stir-fried, pickled, dried, and incorporated into dumplings. In India, it's called kulfa and appears in both vegetable dishes and traditional medicine. These are not marginal specialty preparations eaten by food enthusiasts trying to be interesting. These are everyday foods, eaten by hundreds of millions of people, sustained by culinary traditions that predate the Roman Empire. The archaeological record confirms just how ancient and widespread this use is. Purslane seeds have been found in Greece stored in clay vessels dating to 1050 BC. Pliny the Elder documented it in Roman agricultural writing. It appears in medieval English herbals and apothecary records. Mahatma Gandhi listed it among his favorite foods, and it was grown deliberately in Thomas Jefferson's garden at Monticello, listed in his planting journals alongside his other cultivated vegetables, not as a curiosity, but as a food crop. In colonial America, purslane was a salad green. European settlers knew it as food. They had brought that knowledge across the Atlantic. The transition from food to weed happened in lockstep with the industrialization of American agriculture after World War II, a period when farming consolidated around a small number of commodity crops, when the chemical industry scaled herbicide production using wartime manufacturing infrastructure, and when the definition of a productive farm shifted from produces diverse food efficiently to maximizes yield of a single patented crop with minimum labor. In that model, purslane had no place, not because it was harmful, because it was uncontrollable. Here is how to identify purslane with certainty. The stems are red to reddish pink, thick and smooth, never hairy, which matters because some plants that look superficially similar have hairy stems. The leaves are paddle-shaped, succulent and waxy, growing in clusters at the stem joints. When you break a leaf, it's thick and juicy inside, not fibrous. The flowers are tiny and bright yellow, tucked between the leaves, opening only in morning sunlight. The whole plant grows low and flat, spreading outward along the ground rather than upward. If you find purslane, here is what to do with it. Young purslane, harvested in the first 6 weeks before it flowers, is tender and mild. Remember that Cretan study, the one that produced 70% fewer deaths? Here is exactly how to recreate that salad. Toss a handful of fresh purslane with sliced tomatoes, cucumber, olive oil, lemon juice, and crumbled feta. That's it. That is the dish eaten daily by the population with the lowest cardiovascular mortality Ansel Keys had ever measured. Cooked purslane behaves like a cross between spinach and okra. It wilts quickly in a hot pan, releases some liquid, and develops a silky texture. Sauté it with garlic and olive oil as a side dish. Add it to soups and stews in the last few minutes of cooking. In the verdolagas preparation from Mexico, it is braised low and slow with pork. The purslane absorbs the fat and becomes deeply savory. Pickle it. Blanch the stems briefly, pack them in jars with vinegar, salt, garlic, and whatever spices you prefer. Pickled purslane keeps for months and retains its nutritional profile remarkably well. Blend it into smoothies. The flavor is mild enough that it disappears behind fruit, and you're adding a concentrated dose of omega-3, vitamin E, and minerals to something you were already drinking. One practical note: purslane contains oxalic acid, the same compound found in chard and beet greens. For most people, this is nutritionally irrelevant at normal serving sizes, but if you have a history of kidney stones, cook it rather than eating it raw. Heat reduces the oxalic acid content significantly. If you want to grow it deliberately, scatter seeds in a sunny spot with poor, well-drained soil. Water once and do not fertilize. Purslane thrives on neglect. Rich soil and heavy watering actually produce inferior plants with less nutritional density. If it is already growing wild in your garden, the only thing you need to do is stop killing it. Let some plants go to seed at the end of the season. One plant's output will reseed your entire garden for years without any further effort on your part. The Purslane story is not an anomaly. The same pattern, a nutritious, resilient, uncontrollable food plant, reclassified as a pest once it became incompatible with industrial agriculture's economic model, appears repeatedly in the history of food. But Purslane is the clearest case, because the gap between what it is and how it is treated in America is so stark. A plant with peer-reviewed evidence of cardiovascular protection, a photosynthesis system unlike anything else on Earth, a culinary tradition stretching back 4,000 years across dozens of cultures, classified as a noxious weed, targeted by a multi-billion-dollar herbicide industry, removed from American diets within living memory. The question worth sitting with is not really about Purslane. It is about what else we have been taught to destroy that we should be eating. What else is growing freely, requiring nothing, producing genuine nutrition, and classified as a problem because it cannot generate recurring revenue for someone. Purslane has been in sidewalk cracks outside American homes for the entire duration of the industrial food system. It was there before Roundup. It will be there long after, patient, persistent, unkillable, waiting for the moment we decide to remember that it is food. You cannot kill it without actively, persistently trying. Which means the only thing that has changed in the last 70 years is that Americans started actively trying. Stop trying. The most nutritious salad green in the Western Hemisphere is already growing in your driveway. It costs nothing. It requires nothing, and it has been waiting patiently for you to remember that it is food. Next time you're walking to your car, don't look for a management problem. Look for the red stems and paddle-shaped leaves. When you see them, you'll realize the weed wasn't the plant. The weed was the idea that we needed to pay for poison to fix a driveway that was already trying to feed us. If this changed how you see your backyard, hit the like button to help someone else stop spraying their lunch. Check the description for the peer-reviewed data, and let me know in the comments if you found Purslane in your own cracks. Stop trying to kill your dinner. I'll see you in the next one.